Hello students, welcome back to my YouTube channel Data Shah. In today's lecture, we'll be talking about probability. What do you mean by probability? So there are certain terms that we need to understand before solving the questions of probability. So to start with, probability it means by chance. What are the chances of happening of anything? So like how probable it is that it will rain today? What are the chances that you will pass in the exam? So all of this leads to probability. So there are certain terms that we need to understand before we come to the definition of probability. Like what is an experiment? So any operation that results in two or more outcomes is called an experiment. Like whatever, giving an exam, either you will pass or fail. It could be more than two outcomes as well. So performing of an experiment is known as a trial. So in many questions, you would might have heard about the term trial. So whenever you perform an experiment, that's a trial. How many times you are doing it? Two times, three times. So that becomes the trials. Okay. Random experiment, it is defined as an experiment in which all the possible outcomes are known and which can be repeated under identical conditions, but it is not possible to predict the outcome of any of it. So, random experiment, obviously, you know the outcomes, like we toss a coin, so we know either you will get a head or a tail, or you roll a die, so you know either you will get one or two, three, four, five, or six, anything. You are playing cards and you are just taking a card from that pack of cards. So you know that what could be the outcome. So that's the random experiment. Then we talk about sample space. Sample space is basically the set of all the possible outcomes of the experiment. So whatever um, outcomes you have, like for example, if I am throwing a die, so my sample set would have heads and tails. So we generally denote the sample set by S, and because it is a set, so we use the set form to represent it, and it is written like this. So either I'll get a head or a tail. So there are only two possibilities, two outcomes whenever we throw a coin. Similarly, I have taken various examples. Sample space for throwing a fair die is 1, 2, 3, 4, 5, 6. If you toss two unbiased coins, so obviously would be the chances either you will get two heads, two tails, one head, and one tail, like this. Okay. So one another way of finding out that what could be the total number of elements in your sample space, like here in the number of elements are 2. Here the number of elements are 4. Here the number of elements are 6. So like in a coin we have two possibilities, right? So I'm only talking about the coin right now. So it would be the total n of ns. That means the number of outcomes would be 2 raised to the power n. So here this denotes the number of outcomes, right? And this n denotes the how many times you are we toss the coin. So if you are tossing it once, so you will get two outcomes. Tossing it twice, you will get 4. Tossing it 3 times, you'll get 8, and so on. Similarly, when it is a dice, then what would be the number of the outcomes? It would be 6 raised to the power n. So if you are throwing a single die, you will get 6 outcomes. If you throw a pair of a dice, then you will get 6 square, that is 36 outcomes. So, and so on. So this is how you can find out the number of elements of the sample space. Now, let's come back to the next definition, that is event. And that's very, very important. So any subset of the sample space is known as an event. So event, it is also known as elementary or a simple event if it contains only one sample point. So for example, here I have written If throwing a die, the event A of getting a number 2 only, so it has only single element. So that's a simple event or an elementary event example. Now, for example, I have this two unbiased coins. I am tossing it, sorry. So this is my sample set. Now, the event of getting tails, I mean, at least one tail. So that's an event. So if I take this to be as B, then how many elements are I am talking about? What would be my set be? It would be HT, TH, TT, because I'm talking about at least one tail. So it would be HT, TH, and TT. So I will get three elements here. So obviously it is a subset of my sample space. Now, two things that you need to understand. In the event, we have two kinds of events, impossible and sure event. So the impossible event means that it can never occur. So if I say in Delhi, right now, it's winters going on. So what is the probability of getting a snowfall here? So that's an impossible thing because in Delhi, right now, we are not expecting any snowfall. Obviously, maybe later, this is 2025, maybe after 5, 6 years or down the line, 10 years, we might have snowfall here, but right now it is not possible. So it's an impossible event. Similarly, I have taken one example. If we throw a die, the event of getting 7 is an impossible event because we only have the numbers 1 to 6 on the face of the dice. So the probability of the impossible event is 0. So the P of A is 0. And if it is 0, then obviously it is an impossible event. So it's a two-way thing. So if event is impossible, obviously the probability is 0. And if you know the probability is 0, so automatically you will come to the conclusion that the event is impossible. Now, the other one is the certain or the sure event. Yes, this will happen. Like for example, if I throw a die and I'm asking you, you will get a number less than 7. Exactly, I'll get a number less than 7 because all the numbers 1, 2, 3, 4, 5, 6 are less than 7. So that's a sure event. So again, if the probability is 1, then we say that the event is a sure event or a certain event or the other way around. Now, let's come to the important terms now. The first one is exhaustive. Exhaustive means when you are talking about the total number of all the outcomes. Like for example, if I toss a coin, there are only two possibilities, heads and tails. So that's the exhaustive events. Getting a head and getting a tail. Only two events are there. Now, if I throw a die, there are 6 exhaustive cases. So 1, 2, 3, 4, 5, 6, they can turn up whenever I throw a die. Okay, so whatever event it could happen, like if I am tossing two coins, so these are the possibilities that I have. So if you are talking about the events, so exhaustive events means you are getting heads, you are getting tails. You might get heads and tails. So one head, two heads, two tails. You can't have three heads in this. You can't have three tails in this. So that's an impossible event. So exhaustive cases would be you are talking about the total number of all the outcomes in the trials. So that would be the exhaustive events or the exhaustive cases. Then the independent events means that the happening of one event doesn't affect the happening of the other event. For example, if I toss a coin, then the event of getting a head in the first time and then I toss it again, then again you are getting a head or a tail. They both are independent events. It doesn't matter that whether it is not dependent actually. Similarly, if you are from a pack of 52 cards, you are drawing multiple cards. Maybe I want to draw two cards. So whatever you draw in the first card doesn't. I mean, you have drawn maybe King of Hearts. So the second card is not dependent upon the first card because you are drawing it randomly. So second card could be an ace, second card could be 10 of any suit. So it is not dependent. So that are known as independent events. And obviously, when we can see certain dependency, then we say that those events are dependent events. Okay. Now, the favorable events or the cases, favorable means the number of cases favorable to an event in a trial is the number of outcomes which entail the happening of the event. Like, for example, I am throwing two dice. So, the number of favorable cases that I should get a total of five are these. Okay. So how many are there? So you will see, you can count them, and there are total four number of cases. So the total of four. Similarly, if from a pack of cards, the number of cases favorable to drawing an ace is four. So there are four different suits, and from all the suits, we have four aces. So I can draw it, right? So these are the favorable events or the cases. Then we talk about the mutually exclusive events. So sometimes exclusive and exhaustive are written together, so we get confused. So exhaustive, remember, it is the total number of all the possible outcomes, right? Now exclusive means that the happening of one of them, I mean, if we are talking about two events, then the happening of any one of them precludes the happening of all the others. That means no two of them um, have anything in common. Okay. So, for example, I am tossing a coin. So I am saying either I will get a head or a tail. Do they have anything common between them? No. So there is nothing that they are not even dependent events. They are independent. Either you will get a head or a tail. So mutually exclusive would be, okay, I'll take another one. Like if you are throwing a die, you have 1, 2, 3, 4, 5, 6. Now I have two events. This is my sample space. So the first event is getting even number. So that would be 2, 4, and 6. And my second event would be getting an odd number. So that would be 1, 3, and 5. Now, 1, 3, 5 and the even numbers 2, 4, 6, they are mutually exclusive. But one thing you will see here, my A union B is S. So that means the events that I have taken, A and B, are mutually exclusive and they are exhaustive events. So this is a good example when we talk about mutually exclusive and exhaustive events. So you can understand it very easily. So you have a sample space. So both the events, when you take when you take the union, it is not the, just a second, let me just, it's not the intersection. Actually, it is the union. I'm so sorry. So A union B is S. That means when you combine all the elements of both the sets, you will get the set S. And there is nothing in common. So I can say that the A intersection B is 5. 5 means 0. There is nothing in between the intersection, right? So that's mutually exclusive and the exhaustive events. I hope this would be clear enough. Easy to understand. Now we come to the equally likely events. The events are said to be equally likely if every uh, event has an equal chance. Like For example, I told you that the above, I have written these. These were the examples for the bottom one. So I'll just cut it and show it to you here. So you would be able to understand it much better. So when you toss a coin, head and tails are equally likely events. That means their probabilities are same. So probability of getting a head is half and probability of getting a tail is also half. So they are equally likely events. Similarly, if you throw a die, the probability of getting a 1 is 1 by 6. Similarly, probability of getting a 2 or 4, or you will say 3, 5, 6, they all are same. So the probability, if you throw it once, it is 1 by 6. If you toss a coin once, it is also half, right? I'm not talking about tossing 2 coins or throwing 2 dice. It's just I'm giving you example of 1 coin and a 1 dice. Now, here also, if we draw only 1 card from a well shuffled pack of 52 cards, so the probability of getting anything, I mean, you want mm, um, heart, king. So that's 1 upon 52 because there is only 1 heart king in the 52 cards. So that's 1 upon 52. So that's equally likely events. Now, last we have the compound events. The compound events obtained by combining together 2 or more elementary events are known as the compound events. So getting a 5 or a 6 is a compound event. So generally we talk about elementary events means the simple events. Elementary means the simple events. So it has only one element in the sample space. So getting a 5 is 1, getting a 6 is 1. So when you say, okay, we can combine them, either I get a 5 or I get a 6. So we can find out the probabilities. Now, finally, we come to the definition of what do you mean by probability. So suppose in a random experiment, there are n exhaustive, equally likely outcomes. Let A be an event. So there are m outcomes which are favorable to the happening of it. So the P of A, which is defined to be the probability of happening of an event, is defined as the total number of the favorable cases of happening of that event upon the total number of the exhaustive equally likely cases. So that means, so we are talking about here the number of the favorable cases, which is equal to m, and the number of exhaustive equally likely cases, which is n, which is given to us. So that's m upon n. So we can see here it is written. So from the definition itself, we can understand that m lies between 0 to n. So when you divide the whole equation by n, you will get to know that the probability of any event lies between 0 and 1. So this is the first property of the probability, that the probability of any event lies between 0 and 1. It could be 0, it could be 1, but it always lies between 0 and 1. So there are 3 possibilities only. So we have already discussed. So if it would be 0, then it would be an impossible event. If it is 1, it is a sure or a certain event. Otherwise, the probability will lie between 0 and 1. Now, the number of cases favorable to the non-happening of an event of the event A would be n minus m. So P not of A is also denoted by A complement or A dash, or we say it as the complement of set A. Complementary event also we call it. So there are different terminologies. So we say that P not of A would be n minus m upon m. Not m, sorry, that would be n. Let me just erase it. So when you will write it like this, so you will get to know this is 1 minus m upon n, and m upon n is nothing but this. So that's how we got to know that P of A complement is 1 minus P of A. And from there, we get to know the another property that says of probability that P of A plus P of A complement is 1. So there are 4 properties that you need to understand. First, that the probability of any event lies between 0 and 1. Second, the probability of sure event is 1. Probability of impossible event is 0. And the P of A plus P of A complement is equal to 1. So there are certain questions that we could do, and let us do it one by one. So the first one, so 8 tickets are numbered 1 to 8. A ticket is drawn. We need to write the sample space and the event A of getting a ticket with odd number. So first of all, what would be our sample space? Let us define with the capital S. So it would be the set with all the numbers going from 1 to 8. Very simple to understand. Then we want the event A is defined of getting the ticket with odd number. So this is how we can define it. And the A is the set 1, 3, 5, 7. Now, if we ask after this, what is the probability of getting an odd number? So the probability of getting the event A, I mean P of A, would be the number of the favorable cases. So the number of favorable cases are 4 upon the total number of the equally likely cases that we have. So it's 8. So that's half, that is 0.5. And you could see that it lies between 0 and 1. So it was not given the question to find out the probability, but I found it myself. So that was easy to figure out. Now let's come to the second question. There are 2 children in a family and the events that both the children are boys. Sample space, first of all, it could be either both could be boys, one boy, one girl. First one girl, other boy, or both are girls. Now in the first part, we just need to find the events. So I'm just finding the events only. So if A is the event of getting both the children as boys, so A would be this, right? Second, only one of the children is a girl. So if I take it to be as C, don't take it as B. So one is girl, only one is girl, they are saying. So there are only 2 possibilities. Then third one, there is at least one girl. So now there is at least one girl means that 2 girls can also be there. And the older child is a boy. So older child is a boy means that the first child is a boy. So the probability in this case, oh sorry, the event in this case would be either BB or BG. So if we need to find out the probabilities of these, we can easily find it. So the probability of getting A would be 1 upon 4. Probability of C would be 2 upon 4. Probability of D is 3 upon 4. Probability of E would be 2 upon 4. So this is how it is very easy to find out the events and again the probabilities. Now we have one last question. So an urn contains 4 red and 6 yellow balls. So let me create an urn here. So which is having a basket. Urn means a basket. So we have red 4 and we have yellow 6. So that means we have total 10 balls. Now 2 balls are drawn at random from the urn. Find the number of elements in the sample space. So now when we start this, we know that the total number of balls are 10, that is 4 plus 6. Now the number of elements in the sample space, that is S, is nothing the number of ways of selecting 2 balls out of 10. So it is nothing but the number of ways of selecting 2 balls out of 10. So here we'll be talking about the combinations now. So how we can select that? That would be 10C2. So it would be so 10C2, we'll know how to calculate the combinations. So it would be 10 factorial upon 2 factorial into 8 factorial. So this would be into 9 into 8 factorial. I can rewrite 10 as this. 2 factorial means 2 into 1. 8 factorial is as it is. So it just cancelled out. So 2 5s are. So that's 45. So there are 45 elements in S. Now, when we talk about the number of, find the number of elements in the event of getting both the red balls. Now, when we talk about both red balls, let's just let the event A be getting red balls. Then we can say the number of elements in A would be, so red balls we are talking about. So from 4 red balls, we can have 2 and the yellow balls are 0. So either you can just write it or you can exempt it. So it could be 4C2 only. So when you open this, it would be 4 factorial upon 2 factorial. If you don't remember the factorial, sorry, the combinations, it is n factorial upon r, n minus r factorial. And then this is 6 factorial upon 0 factorial, 6 factorial, cancelled out. We should know that 0 factorial is 1. So this is so we have a total of 6. So now the number of elements in A is 6. Now when one is red and the other one is yellow, so we'll calculate the probabilities later. I'm just leaving the space. So let B be the event of getting 1 red and 1 yellow. So the number of elements in B would be 4C1, 6C1. So out of that, we are getting this. So 4, 1, 3, 6. That's 24. So there are 24 elements for B. And lastly, for C, let C be the event of getting 2 yellow balls. So it would be the same. So the number of elements in C would be 4C0, 6C1. This is 2, I'm sorry. So this just cancels, it is 1. So that's 15. So now let us talk about when we need to find out the probability of getting 2 red balls. So here it was 2 red balls. So the probability of getting 2 red balls, that means A would be the number of elements in A, that is 6, divided by the number of elements in the sample space, that is 45. So we get 2 upon 15 as the probability. And the number probability of getting 1 yellow and 1 red would be 24 upon 45. So that's 8 upon 15. And lastly, the probability of getting 2 yellow balls, that is C, probability of C would be 15 upon 45. So that's 1 upon 3. So this is how we can deal with the questions. So you can just go through it once again, what we were asked in this question. So thank you very much. And please do subscribe to my YouTube channel if you have not done up till yet. And in this series, in the next lectures, we'll be talking about the theorems of probability, Bayes theorem, conditional probability. We have many more lined up. So do subscribe to my YouTube channel. Thank you so much.